This is problem number 6 on the sample test problems for test number 1. A, if the function pictured below is a polynomial, what is the smallest degree possible for the polynomial? So first thing I'll look at here is flat points or critical points. So there's a flat point down there at the bottom, another one up here at the top, and then one more right there. So we see 3 critical points. And what that means is that the degree is at least 4. So we know that the number of critical points of a polynomial is usually 1 less than the degree of the polynomial. So 3 critical points, bump that up to a degree 4. And then the other thing we can say about that is if it's degree 4, then we could think about end behavior. I see as we go to the right, this function goes up forever. And as we go left, the function goes down forever. And that is not what a degree 4 polynomial does. A degree 4 polynomial would do the same thing on the far right and far left. So if it went up and right, it would have to also go up and left. They could also both go down on the far right and far left, but this opposing behavior where one of them goes up and the other goes down, that's indicative of an odd degree polynomial. So if the degree is at least 4, but the end behavior says the degree is odd, then our conclusion here is that the degree, the smallest possible degree here, would be 5. It's more than 4, and it's bigger than or equal to 4, and it's got to be odd. So it could be 5, could be 7, could be 9, but it said we want the smallest possible degree. So the answer there is 5. Okay, so let's move on to part B. It says sketch the graph of the derivative of the function pictured below. So let's see if we can get both of these on the screen at the same time. Go there. So the first thing I'm going to do is indicate the same flat points as we did before. So it's flat there, and flat there. And so then if I'm thinking of graphing something on the derivative, which would be down here, then the coordinates are supposed to be whatever the x coordinate is, comma, slope. And so I'll start writing ordered pairs of points. This point right here, the x coordinate looks like it's 2, and the slope of that purple tangent line is 0 because it's horizontal. Up here, the same idea. The x coordinate is 0, and the slope of that tangent line is 0. And then finally over here, it looks like the coordinates are -3 for the x, and the slope is again 0. So I'm going to plot those 3 points, and those are going to be ones that are tethered to the x-axis, 2, 0, 0, 0, and then -3, 0. And then you have some choices here. You can either just think about where this original top function is increasing or decreasing, and that tells you the sign of the derivative, which we'll graph below. Or you could pick a few points and estimate slopes of tangent lines. That's probably a little bit more accurate, but to be honest, it doesn't much matter to me which way we do it. So for example, we could pick a point out here and say, okay, this one has some positive slope, and then another point in here someplace. That's another positive slope. And then over here, some negative slope. And then finally over here, a positive slope. And so if we're just making up numbers, I won't even be specific with these numbers. I'll just say that over here, it's some x and then some positive slope. And then the next green line is another x and some positive slope. And the next green line, some x and then a negative slope. And then finally, this one is positive again. So really all I'm looking for here are some positive or negative slopes, and then we can kind of connect the dots when we're done. So the first point on the far left, this one here, is someplace out here on the left, and it's a positive slope. So I'll just kind of pick a random number. Again, if you wanted to count boxes up here, just be careful with the scales, but it is some positive slope there. So that point goes straight down here to some positive slope, some positive y value. And then this point is going to come straight down here and again go to some positive y value. Looks like it's about the same slope as the other one, so I'll put it at about the same height as the other one. This point is some negative slope, So it's going to go down here somewhere. And then finally, this is a positive one, and it looks like that's a tiny bit steeper than the other green ones that we drew. So we'll go ahead and make it a little bit higher. So maybe something like that. And then we just connect the dots with some smooth curve. So the derivative was a positive number, and it hit the x-axis, and it's going to bounce around and hit this point right here. Now, I don't know if that's the highest point. It could go a little bit higher. It's okay if it doesn't. And then we're going to hit that point and go through. Down there at the bottom, well, that might not be the bottom. It could go a little lower. We'll hit the x-intercept at 2, and then it looks like it's going to be growing on that side. And actually, the graph that we just drew there kind of gives more credence to our guess about the degree. So I'll just remind ourselves up here, we guessed that the degree of this original was 5, which would mean the derivative would be a degree 4. And so if I look here, and as a separate question, if I just said, what's the degree of this green graph? You'd say, okay, let's count the number of critical points. 1, 2, 3. And if there are 3 critical points, then it's probably a degree 4 polynomial. So if that's a degree 4 polynomial, then the original makes sense as a degree 5.